We are up to skills homework 7. Drawing graphs, 2 lines, 2 scales, 3 line graphs. Wow. So, question 1. 2 different organisms, a goose and a bamboo plant, were measured for growth over a period of time. And we're measuring one thing with one, a goose, mass and height with the bamboo. So 2 different organisms, 2 different things we're measuring. Draw 2 graphs of data on the grid provided using 2y, and then similarities and differences. And this is what we have. So 2 y's but 1x. So our 1x is going to be there along the bottom. So that's going to be age, because we look there, age 0 to 36, age 1 to 13. So this is going to be age of organism. The units are the same. That's going to be in weeks. And then we're going to have 2 y-axes. So we're going to have 1 y for the goose weight in kilograms. So we're going to have a goose weight in kilograms, and I'm just going to copy that down exactly how it is there. And then on the other axis we've got bamboo height in meters. Bamboo height in meters. These scales now, we've got to choose a scale. They're actually handily exactly right. So if we get from 0 there, we need 36, and actually we have nicely 36 of these squares going across. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and our 36 is going to fit on there. And I can draw that line on there. As ever, you'll be drawing these in pencil, and you will have slightly better graph paper. I'm going to draw these in red ink just so you can make it out. But good to draw in pencil, because you make a mistake, you can rub it out. So do your axes in pencil, titles in pencil, points in pencil, line of best fit in pencil, everything in pencil. And then also handily up the side here we've got goose weight in kilograms. Our highest number is 15.3, so it needs to go up to 16. And actually, if we look at these, we've actually got 16 of these divisions here. Hard to make some of them out. It's absolutely difficult with this paper to make these out properly, but we're sort of there. Let's see. And if we went 2, 4, 6, 8, 10, 12, 14, 16 there. So that axis is absolutely fine, and we've got figures at the origin. It's a linear scale, we don't change the scale halfway through, and that would be a normal graph for our goose. Let's plot those data, shall we then? So 0.04, so 0.1, so there's 1, so 0.1, so that's right down there. 3 is 0.5, so 1, 2, 3 is 0.5, so halfway between 1. 6 is 1.6, there's 1.6. 9 is 3, so 9 is 3. 12 is 4.8. 12, 4.8. 15 is 6.8. 15, 6, 7, so 6.8. 18 is 8.7. So 18 is 8.7. There. 21 is 10.5. 21, 10.5, so halfway. 24 is 12.2. 24, 12.2. 27, 13.9. So 27. That's 13. That's 14, so 0.9. 30 is 14.8. 30 is 14.8. 33 is 15.2. So 33 is 15.2. So that's 15. That's 15.2. And 36 is 15.3. So thin line here and 15.3. We are going to join these up dot to dot. So in biology, dot to dot of the data is absolutely fine. If you draw a line of best fit, you can sometimes draw a line of best fit, but sometimes you end up making up bits of data or doing it slightly wrong. Whereas in biology, if you just do the dot to dot, you are going to get the marks in the exam. And why would you do it any different? So I'm trying to get these, I'm putting my pen down in the middle of the cross, and then I'm making sure that the line goes to the center of the next cross. And I've actually tipped my paper up so I can do that more accurately. So there's our line for the goose, and we need to label this goose. Okay, and then we are putting the bamboo data on here as well. So, but we're going to use this scale on the right, so it's also a y-axis. And what's our highest? It's got 14.2, so it's going to be, well, actually the same scale as this other one, rather handily again. So again, we can do our scale here. I'm just going to do these in twos. Pretty tricky to pick out the actual line on this graph paper. Here we go. And again, it's going to be 2, 4, 4 slightly off, isn't it? There's the line. If I'd done this in pencil, I'd have just been able to rub it out. That was deliberate, just to show you how useful a pencil would be in drawing these. We've got our axis labels with units, so we just need to plot the data now. So age 1, so it's not starting at 0, it's starting at 1, okay, and it's 1, it's a 0.8. 2 is 1.4, 1.4. 3 is 2.1, 3 is 2.1. 4 is 3.4. So 3.4. 5 is 5. 5.0. 6 is 7.2. So 6 is 7. 9.2. 7 is 9.0. So 5, 6, 7 is 9.0. 8 is 10.8. 8 is 10.8. 9 is 12.1. 9 is 12.1 there. 10, 13.0. 11, 13.6. 12, 14.0. And 13, 14.2. So 13, 14.2. If we'd have drawn this bamboo data on its own, we would have used a slightly different x-axis, but as we're putting them on the same one, we need to cover both sets of data. And again, a little bit tricky, but I'm just drawing dot to dot with the points. And I know that I'm going to get the marks if I do dot to dot with the points. I'm trying to be as careful as possible to get to the centre of the X. Whoever marks this might have a tolerance of one small square or one small division, but you need to get this as close as you can. Try not to go past the points, and it's very tempting here to draw that down to the 0. But we don't have any data for 0, so we can't do that. We can only draw the line of best fit to cover the data that we've got. So no extrapolation. And we're going to label that bamboo. So two different y-axes on the same graph. And reminder of the question, discuss any similarities or differences. So we've got a graph. Let's just check this graph first. We've got two scales, units, axes names, lines with line of best fit, dot to dot, and labels, and no extrapolation. And similarities and differences. Well, these are actually similar sorts of shapes. We've got both start off growing slower, the rate of growth is a certain level, then the rate of growth increases, and then the rate of growth declines, but always growing until we've got nearly kind of a flat at the top. So both starting to level out. We could possibly suggest that bamboo actually grows to its kind of maximum height in a shorter time period than the goose. So the goose takes longer to get to its maximum height, whereas the bamboo is quicker there. We could add numbers. We could say the bamboo is getting to its maximum height, just past 13 weeks. And its maximum height is just over 14 meters, whereas the goose takes 33 weeks to get to maximum height, which is 15 kilograms. So both similar shapes, both slow growth, then rapid, then it levels off when fully grown. We could say bamboo reaches maximum size faster than the goose, and we could have numbers, for example 13 weeks for bamboo, 33 weeks for our goose.